Hi, class. Hi, class. In this recording, we're going to be focusing on the neuroglia, the supportive cells of the brain, what they are, and some key things they do for our bodies. So let's dive into it. When we talk about the neuroglia, sometimes we refer to them as glial cells, in addition just to referring them as neuroglial cells. So pull this up here. They're also known as glial cells, and they're very numerous. They outnumber neurons, or the cells that generate action potentials in our brain. Neuroglia outnumber them about 10 to 1. So there's many, many more neuroglia than there are neurons. What do these neuroglia do for us? Many different things. They form protection, they connect, they migrate, or they help guide or manage the movement of neurons in the body as the body is developing. And then when we're looking at a mature neuron, those mature neurons need neuroglial cells to have good synaptic contact. When we think of synaptic contact, this is going to be referring to the connection that allows for an action potential or electrical signal to go from one neuron to the next neuron. We don't want neurons touching each other except where they come into very close proximity to each other for synaptic contact. So by preventing neurons from physically touching each other, these neuroglial cells help control the electrical activity of the brain. It gives our neurons the ability to not have a short circuit, so to speak. Our neurons won't have the electrical signal jumping to inappropriate parts of the brain. So we'll first talk about neuroglia of the central nervous system. And within the central nervous system, there's 4 kinds of neuroglia. First, we have the oligodendrocyte. I lovingly refer to these as the oogly boogly cells. And when we think about these oligodendrocytes, they are going to form myelin sheaths within the central nervous system. So here we can see a oligodendrocyte. And that one oligodendrocyte is going to send out podocytes, or extensions, multiple extensions to multiple neurons, and each extension will wrap around a section of the axon of that neuron, myelinating one section of that axon. Here's another oligodendrocyte with more podocytes, or pseudopods, I should say, not podocytes, pseudopods. I misspoke when I said podocyte. And we have those pseudopods coming out here, wrapping around. We also have ependymal cells. Ependymal cells are a ciliated columnar epithelium. And as we look at these ependymal cells, we can see some of them right here. Typically are going to form a membrane that is going to be exposed directly to the cavities within the brain. Cavities within the brain are referred to as ventricles. And within those cavities, they secrete CSF, cerebral spinal fluid. Depending on where you section them, occasionally they can look like cuboidal epithelium. As I look at this figure right here, to me, that appears to be more columnar epithelium. We also have microglia. You can think of microglia as the white blood cells of the brain. More specifically, they're the phagocytes, or the phagocytotically active cell of the brain. And as we look at these microglia, they are going to have some branch-like extensions coming off of them, and they are also going to be able to phagocytize pathogens within the brain. We also have astrocytes within the CSF, or the central nervous, or CNS, the central nervous system. And as we look at these astrocytes, the root word here is astro for star, cyte for cell. Astrocytes are cells with many branches coming off them. They look like a star to early anatomists. And as we look at these astrocytes, they are very abundant because they have many, many different functions. As we look at these functions of the astrocyte. For instance, they form a supportive framework within the brain. They help to keep the spacing between cells correct. They have perivascular feet, and these perivascular feet, if we look at this name here, peri and then vascular, really illuminates what they do. These astrocytes will send an extension to a blood capillary, and then will wrap an extension of their cell body around a blood capillary. What do these perivascular feet do as they wrap around the blood capillary? They stimulate the blood cells, or excuse me, the blood vessels themselves to form the blood-brain barrier, a very tight seal that makes it very difficult for things to get into the brain that do not belong in the brain. Astrocytes are going to also monitor neuron activity, regulating the blood flow in the brain to help match metabolic need. Astrocytes are capable of taking glucose and converting it to lactate. And this lactate is then going to be supplied directly to the neurons. And then finally, astrocytes are also going to regulate the chemical composition of the brain. And as they're regulating the chemical composition of the brain, they will help modify the blood-brain barrier and also modify some of the ions present within the cerebrospinal fluid to influence the overall environment, the extracellular environment of the brain. So that was the central nervous system. Let's move on to the peripheral nervous system, the PNS. As we look at the PNS, we are going to have Schwann cells, which are analogous to the oligodendrocytes of the central nervous system. A key difference between a Schwann cell and a oligodendrocyte is one Schwann cell will wrap around one section of one axon. As we look at a Schwann cell, I always like to they remind me of cinnamon rolls, because when you make cinnamon rolls, you take your dough and you roll it up on itself multiple times. And then we just have to do the one last step where we would slice it to make it into those individual cinnamon rolls. But I know most people don't bake as much as I do, so that's fine. As we're looking at these Schwann cells, the Schwann cells have multiple layers. They are laminating themselves around the individual section of the individual axon. They're repeatedly winding themselves around the axon. And in the peripheral nervous system, they help guide the regeneration of damaged nerve fibers. And when we think of a damaged nerve fiber, I want you to think of the axon of a neuron. They're the same thing. As we look at satellite cells are going to surround neurosomas of the ganglia within the peripheral nervous system. So here we can see a unipolar axon, unipolar neuron. And as we're looking at this unipolar neuron, the neurosoma of it is going to be right here. And then wrapped around that neurosoma are individual satellite cells. What do the satellite cells do? They electrically insulate the neuron from the surrounding environment, and they also chemically insulate it, in addition to electrically insulating it from the surrounding environment. You could think of the satellite cells as a miniature blood-brain barrier for the peripheral nervous system. And that's all we have for this recording on the neuroglial cells. We talked about the neuroglial cells of the brain, or the central nervous system, and the neuroglial cells of the central or peripheral nervous systems. If you have any questions, please feel free to post them in the class discussion boards, shoot me an email, and as always, happy studies.